Good afternoon, ladies and gentlemen. I am Dr. 𝙀𝙤𝙜𝙤𝙬𝙧, the past chair of ACGSA. Welcome to our first ACGSA webinar of the year 2025. ACGSA is Architect Regional Council of Asia Committee on Green and Sustainable Architecture, representing green building experts from 23 Asian country members. Our mission is to work together on ACGSA platform to share knowledge and experience and to provide best practices in green building in Asia region. Our webinar titled Digital Technology in Architecture Towards Net Zero focuses on leveraging digital twin and AI towards carbon neutrality in building design, construction, and operation processes. The objective is to inspire new ideas by learning on digital twin and AI potential and to gain insights on future green building business transformation for stakeholders to advance green and sustainable building movement in Asia. I hope you will enjoy the talk and thank you very much.
Hi, good afternoon everyone. I'm Architect Alice Leong, the ACGSA Chairman, and welcome everyone to today's webinar organized by ACGSA Committee and supported by the School of Architecture and Design, KMUTT, Thailand. Here, I would like to also express my many thanks to Architect Archa, the past chair of ACGSA, for good efforts in making today's webinar successful. Thank you so much. Ladies and gentlemen, today's webinar is related to the transformative role of digital technologies in architecture as we strive towards a sustainable net zero future. Digital tools such as the Building Information Modeling, in short form we call it BIM or BIM, computational design and simulations software are revolutionizing how we design, analyze, and construct our buildings. These technologies enable architects to optimize energy efficiency from earliest design stage, reducing waste and minimizing the environmental impact. For example, BIMs allow for precise coordination among the multidisciplinary teams, ensuring better resources management and reducing material wastage. Computational design and parametric modeling helps create innovative forms that are both aesthetically pleasing and highly sustainable, optimizing natural light, airflow, and insulation. Moreover, digital simulations of energy performance empower the architects to predict and enhance a building's efficiency before even construction starts. This proactive approach is crucial in achieving net zero energy buildings, structures that produce as much energy as they consume over their life cycle. In addition, emerging technologies like AI and machine learning are the futures refining our capabilities and enabling real-time monitoring and adaptive systems that adjust to environment coordination, ultimately reducing energy consumption. Therefore, in conclusion, digital technology is an indispensable ally in our quest sustainable architecture. By leveraging these tools, we can actually design smarter and greener buildings that not only meet our climate goals, but also create healthier and more efficient spaces for people. I believe today's speakers are eager to share and enlighten us more of what they know and their knowledges. Therefore, I would like to hand over this session to Architect Joanne, the moderator of today's webinar session. Thank you so much.
All right. So for our first speaker, we are very honored to have him. Architect Dr. Tony Ip is a community-centric sustainable design architect and urban designer. He is the founder of Tony Ip Green Architects Limited, or TIP, as serves as the vice chairman of the Professional Green Building Council, director of Hong Kong Green Building Council, and director of CIC Zero Carbon Building. He holds his bachelor's in Built Environment Architecture from Queensland University, Master of Urban Design from Hong Kong University, Master of Studies, Interdisciplinary Design for Built Environment from the University of Cambridge, and PhD from Hong Kong Polytechnic University. His passion and contribution to green architecture were recognized by receiving Hong Kong Special Administrative Region Medal of Honor last 2022. Australia-China Alumni Awards for Arts and Creative Industry 2018, and 10 Outstanding Young Persons Award 2016. So please welcome on stage today, Dr. Tony Ip.
Thank you. Thank you for the introduction. Okay, let me share the screen. Okay, can you see the presentation mode? Yeah.
It's not in full screen.
Not yet.
Okay, let me share again. Okay. So is it okay?
Yes, now correct.
Perfect.
Okay, that's great. Let me start. Good afternoon, everyone. It's a pleasure to be here today to discuss a topic that is not just transformative, but essential for our future: AI application for zero carbon architectural design. My name is Tony Yip from Hong Kong Institute of Architects, and over the next 18 minutes, we will explore how artificial intelligence is reshaping the way we design towards carbon neutrality. So Hong Kong, like many global cities, face urgent climate challenges. But with AI, we have a powerful alliance to turn these challenges into opportunity. That's not just incremental progress, it's a revolution. Let's dive in. First, what do we mean by AI in architecture? To me, AI is more than artificial intelligence. It's a layered design partner. First, architect's intuition helps brainstorm freely, turning blank pages into fields of potential. Then, artificial intuition acts as a curator, surfacing the right references at the right moment. Of course, AI is also a solver. Artificial intelligence generates precise options, optimizing constraints, so we focus on what matters. But most crucially, is an architect intelligence, protecting design core, purpose, emotion, and meaning. So AI generate. Does AI work? These are AI-generated designs that I input the tests. AI applications for zero carbon architectural design in Hong Kong. So does these designs really make sense? In reality, this is the first zero carbon building in Hong Kong, built in 2012, and I was one of the architects involved. It may inform that artificial intelligence cannot work alone. It really needs architect intelligence to drive. Now, let's talk about the zero carbon design. Passive design, active systems, and renewable technologies are key drivers to achieve zero carbon. Meanwhile, we tackle the carbon challenge for net zero in 3 layers. Operational carbon, the energy used over a lifetime of a building. Embodied carbon, the emissions from material and construction. Last but not least, carbon offset, either on-site or off-site. Recent research showed that AI can reduce energy consumption and carbon emission by 8% to 90% by 2050. How? By optimizing equipment, occupancy patterns, and even construction methods. Most importantly, during the design stage, AI can help. So AI isn't just a tool, it's a design partner. Here's how it works. First, design optimization. AI optimized and balanced competing goals like daylight, comfort, and air quality with precision. Second, process transformation. AI automates 3D modeling and BIM, enabling real-time adjustments. but we must stay vigilant. Interoperability and data accuracy are critical. Third, smart city architecture. Deep learning predicts traffic, energy use, even carbon storage give us unprecedented foresight. Let's look into key AI-driven solutions. Logic of optimization. For instance, AI can analyze window-to-wall ratios or building organization orientations to maximize natural light while minimizing heat gain. It is subject to how we frame the design objectives, problems, and define the parameters. One of the key concepts of AI generative design is this double diamond model, which structures design into divergent, exploration, and also convergent focus phases. This mirrors machine learning cycle of fitting data and generalizing knowledge. Generative design uses this interactive process to autonomously expand the creative solutions, supported by engagement methods like brainstorming and data analysis. So the key is here. The main roles of AI are for fitting and generalization. Back to zero carbon architectural design. AI plays a key role in zero carbon design by optimizing renewable energy, selecting suitable materials, and reducing emissions. It enhances efficiency in solar and wind, predicts material in buildings, while material and recommended low carbon alternatives. AI-driven smart control, minimizing energy use in building, while urban designs strategies like green roofs, compact heat islands. Additionally, AI improves water management and helps design walkable, low-emission neighborhoods and supporting a sustainable future. Now, let's look at the AI toolbox, transforming architectural design. First, AI tools for site analysis and massing studies, turning weeks of analysis into minutes. There are two different tools here. First is the Space Makers, which uses AI to streamline urban site planning, from 3D modeling and environmental analysis to design optimization, enabling data-driven decisions and sustainable outcomes through collaborative and generative workflows. Similar software, namely Autodesk Former, accelerates sustainable urban planning with AI-driven massing analysis, from geolocated data setup to environmental simulations, enable rapid iteration and performance optimized design based on daylight, wind, and carbon matrix. Another set of tools for energy modeling facilitate architects for design optimization integrated with our design workflow, such as this Autodesk Insight integrates the Revit to analyze energy and carbon performances, while cloud simulations, enabling data-driven design optimization for sustainable through iterative testing of building performance and system. Another software commonly adopted, Climate Studio, provide AI-powered environmental simulations in Rhino and Grasshopper, analyzing daylight, glare, and thermal performance to optimize passive design, occupant comfort, and energy efficiency through parametric workflow and Revit integration. We also pay attention on our embodied carbon and material optimization. So there are other tools for life cycle assessment, LCA. Tolly is one of the popular tools, integrated LCA into Revit workflows, enabling real-time carbon assessment of BIM model by linking materials to environmental data with dynamic updates and detailed reporting for sustainable material selection. Another set of tools which I personally adopt mostly, one-click LCA, leverage AI to facilitate zero carbon design by providing 300,000 over verified data points and enabling early stage optimization. AI solved several key pain points: data gaps, manual LCA processes, and late design stage sustainability integration, while generative tools create low-carbon design alternatives and seamlessly integrated with our BIM model and embedded sustainability into our core workflows. Also, lastly, tools for design communication also very important, especially for collaborations and community engagement. And these tools I also used quite mostly. Clean AI transforms the urban design communication by generating photorealistic, like this, transitional model between the current and proposed scenario, using image inputs and optional text prompts to visualize design proposal and foster community engagement. Let me talk about share some case studies in Hong Kong. First, this is the Hong Kong University of Science and Technology, Hong Kong UST collaboration with the Hong Kong Housing Authority. It shows a generative design platform called AutoSys for residential site design. Okay, let me further elaborate about this model. So this involves the generative design in practice, the generative design by parametric modeling and optimization to evaluate the layout options. The principle behind is the generative AI for buildings layouts employs diverse models, including physical, mathematical, and machine learning, to automate space planning, with tools demonstrating AI potential in architectural cluster design optimization. The workflow automates building cluster design by systematically evaluating combination of block types, floor numbers, positions, and also orientations, while checking the boundary constraints to generate compliant design options. So let's go into some examples here. You can see the option 04, reduce the noise to 18.38 decibel, while maximizing daylighting and natural ventilation area to 6,726 meters square, showing that the AI balancing the competing priorities between the noise control and also natural ventilation and daylighting for passive design. So the parametric model in Rhino and Grasshopper paired with the environmental simulations as shown before, this combo lets architects explore hundreds of variants just in hours, not weeks. Another workflows showing the combines the generative design with prefabricated modules using parametric modeling and environmental simulation to optimize the layouts for energy efficiency. So in this case, we can improve close to 25% and also improve the daylighting over 56% with the output generated in the Revit or Dynamo. Apart from that, some other cases of AI-driven innovations happening in Hong Kong. So this is the project One Taikoo Place. It involved the digital twins, track the real-time energy use, and also the machine learning optimizing chiller plants, adjusting the weather and occupancy. Another project completed in 2020, this is the InnoCell. Actually, this project is the Hong Kong first high-rise built with modular integrated construction, we call it MIC. So all the building component manufactured in the factory and then set up and combined on-site. So in this project, highly adopt the AI, especially in the construction stage. So the AI accelerate it with the 3D scanning together with the BIM and schedule crunch. So the AI streamlined module assembly, slashing construction time reduced by 40%. And the last case I would like to share is this, just newly completed in 2022, the Namfeng Air Sign. And this project is a mixed-use hub in 𝙬𝙤𝙤𝙬, which is our old airport area right now, becomes the new city center. It's an AI platform. Does two things brilliantly. Apart from the design stage, in the operational stage, it helps the tenant experience, analyzing customer foot traffic to optimize retail layouts, and also facilitate the facility management, predicting the HVAC failures before they happen. So they set up the BIM model with the AI integration, not just in construction stage, not just in design stage, throughout the construction, and also pass to the facility management. And right now, it as an example how Hong Kong AI powered the urban future. Okay, so in closing, AI doesn't replace creativity, it deepens it. By merging human intuition with machine precision, we don't just design faster, we design better. From generative design to real-time carbon management, these tools are unlocking zero-carbon architectural design in a scalable, affordable, and achievable way. We are at the tipping point of design paradigm shift. Thank you.
Okay, so thank you very much, Dr. Tony. Just right in time, 18 minutes and even less. Thank you so much. But I hope that everyone is very filled with all about AI. But we're still in the beginning of our session because we still have 3 more to go. And actually, there's a lot of questions running on my mind now. And please, later, write on your questions, or later we will gonna invite you to ask during our Q&A. So please hold on tight. And now for our second speaker, so he will gonna talk about the artificial intelligence as the catalyst for sustainable architecture. So for our second speaker, architect 𝙀𝙤𝙜𝙤𝙬𝙤 is the renowned architectural futurist, sustainability advocate, and design activist. He leads the SA², a hybrid architectural firm known for its innovative, research-driven solutions and international competition wins. Architect 𝙀𝙤𝙜𝙤𝙬 is formerly president of the Pertubuhan Architect Malaysia, or PAM, and Malaysia GBC. He is now serves as the CEO of the Green Building Index and sits on its board of directors. He is also the board member of the Board of Architect Malaysia, or LAM, and the panel of expert member of KPKT. It is the Ministry of Local Government Development of Malaysia, a former editor-in-chief of the Architecture Malaysia. Architect 𝙀𝙤𝙜𝙤𝙬 holds degrees from the University of Liverpool and University Saint Malaysia from 2019 to 2024. He was an associate professor at the University Malaya, where he still served as an industry expert alongside his advisory role at Taylor's College. He is also on the executive committee of the Malaysia Carbon Score and was PAM's ESG committee chair. So please welcome on stage the past president of PAM, Malaysia Green Building Council, the CEO, architect 𝙀𝙤𝙜𝙤𝙬𝙤𝙬.
Yeah, thank you so much, Joanne, for that kind introduction.
Thank you, brother.
Let me share my screen here. I hope everybody, okay. Thank you. Today I will be presenting the artificial intelligence as a catalyst for sustainable architecture. Yeah. So I think the presentation outline, I think we'll try to dovetail as much as possible from Dr. Tony just now. We'll give an overview of AI in construction, how AI has helped sustainability process and the GBI experience, our rating tool, and the sustainability impact of GBI, and the conclusion. Yeah. So I think a lot of times when we think about the artificial intelligence, we think of it as something scary and special. But you think about it, years and years ago, when people discovered electricity, it was seemed to be something that is magical. And we don't notice it now that electricity is everywhere, from your phones, your gadgets, your lights, everything is electricity. And in the future, AI will be like that. Every little bit, your refrigerator, your microwave will have AI. So that's just the reality of things, because we were introduced to AI in a very theoretical and dramatic way. All the cinema says that, oh, AI will take over. And now, actually, in terms of economics, it has a huge impact on our construction market advancement. So those who don't embrace AI will not actually get the benefit of this technology. Like, it's like electricity. If you're somebody that were not using electricity in those days, imagine what advancements were you not enjoying? Yeah. For even a slight tip, like the last year's DeepSeek debacle, DeepSeek was developed very fast by the Chinese. It cost the US $5 trillion in terms of stocks. Yeah. And what is AI? AI is actually volumes of data that is built through intelligent systems. We have basically three types of AI based on capabilities. We have narrow AI for the longest of times, but we have now, why it becomes so popular now is because that we are trying, that it's coming up to natural language processing. It's the memory is getting better, and it's getting to almost a level where you start to think that, hey, is this something that is alive? So that is why it is suddenly the technology has become so advanced in the past few years. Even that people like Elon Musk, even like ChatGPT, Sam Altman gave a statement that, hey, they don't actually understand how AI works. Imagine ChatGPT creator saying this, yeah, out in the open. So in terms of architecture, it is a natural progression. We have modularity. This is from a thesis by Stancis Chiao, yeah. The modularity movement in the 1930s. We have computational design in the 1960s. We have parametricism in the 1990s. And of course, artificial intelligence in the 2010s and above, where we are now. And I think when people ask, well, will AI replace the designer? Of course not. AI will not replace the replace the architects, but it will replace architects who don't use AI. So that, I think that was the point that Dr. Tony just now was mentioning as well, that you need that architect intelligence to actually drive it. And it's actually, technically, it's your assistant. And it's not just about image creation. It's about everything. Yeah? You're writing letters, you're presenting your PowerPoints, your general graphics, you're rendering stuff on visualization, your construction work, all those actually will be affected by many tools that will have AI components. And in fact, there will be so much that your assistant in the future, that your assistants will be talking to each other. So your AI will be talking to another AI. Can you guys hear this audio? No?
No, Architect Charlie.
Oh, sorry. Let me reshare with audio, I think. Hold on. Stop sharing. Share sound. Yeah, sorry. Forgot to share the sound. So in the future,
No, there's no physical damage. It's
your
just not
your
turning on
phones will
despite
be,
trying all
or
the basic
technically your
troubleshooting
own
steps.
AI agent will be
Bummer.
talking
Would
to
Joe prefer to
another
return the
AI
iPhone to
agent,
an
yeah.
Acme Telco store or
So
ship it back?
it becomes a
Shipping it
representation of
back would be the
yourself
best
or
option.
even your work
Could
or
you
your firm.
Oh, got it. When did Joe
And you, as shown by Dr. Ip just now, it can be used for things like project tracking and error prediction. We also use it for like energy use intensity and looking at smart grids. Now you can have in the palm of your hand readouts on energy use, buildings, yeah. We are looking at behavioral predictions of lighting and HVAC, where you already set up your BMS system, your building systems, but you can actually look at how behaviors actually change, which areas are unused, used, yeah. We even up to the stage of autonomous monitoring of the construction waste. This is a product called Pelo, which actually monitors bins, yeah, and sees the intensity of bin use, rubbish use, and it tracks down the intensity of when and what is thrown away. It can also predictive building energy optimization. This is a software called Building IQ, which actually looks at energy usage and tries to optimize loads throughout the day. Again, this is another Building IQ graph trying to rationalize the loads. Carbon Cure is another software that actually looks into injecting carbon into concrete. Yeah? So concrete itself, to capture the carbon inside the concrete. So these are just some examples that I've shown, and I think Dr. Tony just now shown some other examples as well. But because GBI, which I am in charge of now, is actually our rating tool. It's similar to LEED, similar to BREEAM, similar to Green Mark in Singapore. So we have like 742 projects, 30.6 million square meters of certified space. We save about 1.9 million tons of carbon being released to the atmosphere. We have like 18 particular typology of tools, all the way from normal buildings, data centers to hospitals and whatnot. And we have a bunch load of data. So we use AI a lot in GBI when I came in to actually push the agenda of data analysis so that we know which projects, which criteria are people going for, which they are not, which and because we also a country split by a large ocean, we have East Malaysia, West Malaysia and East Malaysia. We want to also corroborate this data with certain other aspects like income or of wealth and whatnot. So we have created this Green Building Index AI assistant. So it's technically an AI agent that support our facilitators, people who submit to GBI, the general public, and also people who check on behalf of GBI and also our staff, so that GBI can actually give better service and people do understand, because a lot of the times things are very technical when it comes to sustainability. Yeah? For example, in our uniform building bylaw in Malaysia, there is a requirement for architects especially to calculate OTTV. So with the Green Building Index Assistant, you can ask it to help you calculate the OTTV, because architects don't like calculation, only engineers like calculation. So you can also ask it to like, this is for U value as well. So you can like, oh what's the U value of your certain design of roofs. So it becomes a lot easier. What takes a long time last time in terms of getting sustainability done is done in a very short moment. We have, as I mentioned, we have 18 tools. So we can compare the tools as well. What's the difference, for example, between our GBI and RNC version 3 and the non-residential tool version 1. So you can get the comparison. And also it it helps the certifier for the certification process. So when they submit to GBI, the certifier do not have to read so much with a lot of documents. It will check, say, oh, does this comply? The indoor environmental quality does not comply, so on and so forth. So it actually helps to actually make our life better and easier. In terms of big data analysis, as I mentioned, they can look at all the tools and look at criteria or whatever matrix that you want it to analyze. And not just that, there are visualization just now, like Dr. Ip mentioned, clean AI, right? You can create videos and whatnot. We have used it to actually help us in communicating, because I'm very busy and sometimes I have created some AI for us to represent GBI.
大家好，绿色建筑指数
So for example,
GBI 是马
this
来
is
西
a
亚
one
受
that
取
is
一致的
speaking
建筑可持续性评级
Chinese.
工
Of
具，
course, I can't
旨
speak
在促进
Chinese.
建筑
I
环境
can't
中
speak
对环
a
境
bit
负
of
责的
Mandarin.
做法。
I see
GBI
Dr.
于
Tony is
2009
smiling all
年
the
推
way.
出，根据能源效率、
So
用水效
we
率、
have
室内
avatars
环
that
境质量和可持续场地规划。
the major languages. So
Hai,
of course in
walaupun
Malaysia,
ini kelihatan seperti saya,
it is Malay.
tetapi ia sebenarnya avatar AI yang boleh bercakap apa-apa skrip.
Or even
வணக்கம், இது என்னை போல்
we have
தோன்றலாம். ஆனால்
in Indian population
உண்மையில்
which
இது
speaks
ஒரு
Tamil.
AI அவதாரம். நான் எந்த ஸ்கிரிப்டை வைத்தாலும் அது சொல்லும். உதாரணமாக Green Building Index GBI
So
என்பது
we have outreach also in Tamil.
Hi, 这看起来像是我，
Oh,
但
this
实
is
际上它是
the
一个人工智能化身，
Man-
它可以说
Mandarin, I
出
think.
我输入的任何脚本。例如，绿色建筑指数 GBI 是马来西亚受取一致的建筑可持续性评级工具，旨在促进建筑环境。
And even in a more, I'm from a Javanese descent from Indonesia. I can't speak Javanese, but my AI
Green
avatar
Building
can.
Index GBI minangka alat rating kelestarian utama Malaysia kanggo bangunan.
So it is a
dirancang
tool
kanggo
that
ningkatake
is
praktik
very
sing
very
tanggung
flexible.
jawab.
That can use that you can utilize to help your daily work lah. So our daily work is outreach. That is a lot. And in terms of architecture, I think Dr. Ip just now showed a few tools that we also have explored and asked our people who are involved in planning. Because the big improvement is that you can do this now in real time and get the environmental performance done in real time, rather than you have to wait for a long time to get the feedback from, and when you change it in real time, you actually get the feedback that you require. Like, it's not just visual feedback, but also performance feedback. This is from Spatio. I think this is what that has become the base for Autodesk Forma. This is a similar program, SpaceMaker. I think Dr. Ip also showed just now. You can see that the planning parameters are interchangeable here. So I'll just speed it up in view of time. So once you have all these planning permutations, you can look at the performance, and so of course the normal daylighting, the exposure to sun, the noise analysis, and all the environmental aspects are done quite easily and fast, so that you can start your design process in a very informed manner rather than it's mostly guessing.
Expensive and customized
This
feasibility
is
studies and
ARC,
floor
which
plans
is
comes in.
actually more
With
towards
ARC, you can quickly and easily create accurate and optimized floor plans that meet your exact specifications. Simply start with the zoning input and lot conditions, customize it, and continue to create
This is
the
more
ground,
for
typical, and
feasibility
setback
study,
floors.
because
All
feasibility
components
study
are calculated automatically
is
and are
kind of
code compliant.
something that everybody
And
needs
that's
to
not
do,
all.
but
With ARC's optimization feature,
usually
you
it's a
can
very slow
automatically
process
create the
because
most
you
efficient
don't,
layout
your
possible
cost
based on your
is something
specific
that's
needs
hard
and
to
requirements,
calculate.
and
But
calculate areas and
with
dimensions.
AI-driven
So,
software
and
like
even
ARC,
to even
it's
begin,
quite
developer
fast. Yeah?
or
I just
broker
skip
and
through
floor
because
plan
there's
for
a
your
whole
next
video on
project.
this. And but that being said, when you use AI, there's a dirty secret. Actually, AI costs a lot of energy, and I'm sure you know this. Where a moment you chat on your chat GPT actually is like 15 minutes of using your phone. 15 to 20 minutes the energy use. Yeah? So the interaction with most of the AI is actually processed somewhere with heavily energy use in some data center. So it uses a lot of water as well, whereby here you can see like 25,000 gigawatts of energy from Google, Microsoft, Meta, Apple, Nvidia, million meter cube of water. Yeah, so it is a huge drain on our resources. So at GBI as well, we look at how to mitigate this data center issue, where we have a data center tool, and now we have just on the cusp of launching our version 2. So data center design is something that is very, very important as well. So when we look at the data center tool that we just developed, it is designed more for Malaysia. We look at our PUE. It's very different from LEED. LEED does not look at PUE so much. I think even some of even comparable to Greenmark data center tool, they're very generous with water. We are very conservative with water. We give more points for water conservation because we want a closed loop system for cooling. I wouldn't want to get into more of the technicalities, but I just want to say that when we use AI, we need to also be responsible for the generation of that data as well. So we please push for more green data centers. Yeah. NVIDIA CEO famously said this: don't waste time learning coding because AI makes coding almost obsolete. Now you can ask AI to do the coding. And as I mentioned before, it is to build intelligent systems. And it does not invalidate the old. Think of it this way: a lot of architects, a lot of designers think that, oh, AI will replace them, but it's not. As like photography, when photography was created, it did not make painting obsolete. And just because you can snap a photo doesn't mean it's a good picture. So the artistic eye, the person behind the camera is still important. Similarly, now the person behind the AI is very important. So I will end my talk with this notion that AI can only copy and rehash like a DJ or remix, but true inspiration still comes from the human soul, as mortality and the human condition gives rise to true artistry. So be original. So thank you.
Thank you so much, Architect Zarly. I really want to ask more, and maybe we can push a workshop regarding this one, huh?
Oh, thank you.
Yeah, thank you so much. We appreciate it. And my takeaway there is, yeah, AI will never replace us, but those who will be replaced are those who's not willing to learn. So please always get this type of attitude that always willing to learn and be like sponge. Okay, so with that, we will gonna give you 5-minute break, just 5 minutes only. Then after that, please get back onto your seat, and we still have 2 more speakers to go. Thank you. Okay, so 5 minutes done for our break. I hope everybody got an opportunity to stretch and think more about what is really the AI's thing that will help us in our built environment. So how it will impact our career, our profession, and the future of architecture and engineering. So to give us the view, speaking of engineering side, our next speaker is Engineer Nehal. So can I have the slide of Engineer Nehal, please? Okay, there you go. So to give a proper introduction, Engineer Nehal Premachandra is a chartered engineer and a project management professional, PMP, with 38 years of experience in design, development, construction, and contract administration for public buildings, airports, and infrastructure development projects. Engineer Nihal started his career as a site engineer in State Engineer Corporation and subsequently joined 𝘲𝙤𝙤𝙜𝙤 𝙤𝙤𝙜𝙤 Group, Public Buildings and Airport Division in 1988. 𝘼𝙧𝙘𝙤𝙤 Free Trade Zone Infrastructure Development Project is one of the major projects he completed in Sri Lanka as resident agent. After 32 years of service in Bin Laden Group, he retired as a project director of Maldives International Airport Expansion Project in 2020 and continued to provide consultancy service to the few companies as an external consultant. Engineer Nihal has managed 3 international airports in Malaysia, UAE, Maldives, and several public buildings in Saudi Arabia, Malaysia, and Dubai as project manager and project director. These public buildings and airports have become landmark buildings to those countries now. Engineer Nihal is a specialist in directing and managing design and build turnkey projects in a certified. Ladies and gentlemen, our colleagues, giving you the floor, and we'll discuss the use of digital twin in construction to reduce carbon footprint. May we please welcome Engineer Nihal Premachandra. You are muted, sir.
Can you hear me now?
Perfect.
Yes, we can.
Yeah. Greetings from Sri Lanka. And of course, among the airports and the iconic buildings that I have got involved in design and construction, Kuala Lumpur International Airport is one of my favorite construction sites, and Putrajaya Mosque as well. Okay, let me continue my discussion on this. Of course, I'm trying to show you how you can use the digital twin in construction to reduce carbon footprint, and showing you the way how to transform the built environment toward the carbon neutrality. Right. Now, what is carbon footprint of a building? Carbon footprint comes from 2 primary sources. One, embodied carbon. That is, you see, when you manufacture any material, you will use fossil fuels, grid energy, and we are fabricating or transporting, again, you use such energy, so that will emit carbon. And the other source is operational carbon. Now, when you finish your building and you have to put lighting, cooling systems, heating, and maintenance, there again, you are burning fuel where you will emit carbon into the atmosphere. You are sort of disturbing our environment. Now, our professional responsibility is to reduce this particular emission. How a digital twin reduce the carbon footprint? You have a facility in digital twin to optimize your design. You try to use less embodied carbon materials. Use materials with less carbon emission in that material. And of course, you can connect the digital twin directly to the CNC machines and bending machines. Do your cutting and bending exactly, reducing the waste. You are reducing waste means, okay, you are reducing the carbon emission. And of course, this informed material selection is also very important. When you are selecting the materials, you choose low carbon materials. Now, there is a certification that all the manufacturers should obtain in their material production to ensure the low carbon footprint. You select such materials where they have EPD certification, right? And look at this. Now, if you look at a steel production, if you use the electric arc furnace to produce your steel, it emits 75% less carbon than that you produce from blast furnace. So you ask your manufacturer or the supplier to give you the mill certificate. If you look at the mill certificate, you will find whether it is EAF or blast furnace slag. So this type of measures as professionals we can take to reduce carbon footprint with the help of the digital twin. Now it is important that you save the quantity of carbon emissions. You can use low E glass instead of normal glass. You can use electric arc furnace manufactured structural steel instead of blast furnace manufactured steel. And you can explain to your customer about energy saving in electrical bills, because when you use low E glass, your cost will go up, but it can be offset by the benefits that you are getting with low carbon emission. Now explain the citizen responsibility to protect the environment by promoting material use with less carbon. That is your duty, because most of the clients, they don't understand this, what is this low carbon footprint at all. So you can always calculate carbon dioxide emission saving in kilograms carbon dioxide emission per square meter for alternative cladding and shading materials. That way you can prove what you are trying to do scientifically. Now, what is the net zero project? Net zero energy building is a building which produces a renewable energy source, energy on site or nearby the site, which is equivalent to the energy consumed by the building on its operations and maintenance. Now, when I was doing the Dubai Sports Complex, we did calculate at the design stage. It was a design and build contract according to the RIBA stage D contract conditions. We did the calculations. We found how much energy, we predicted how much energy is required to run this building. And based on that, we designed a photovoltaic system to generate clean energy to support this particular carbon zero or net zero energy building. Why you say net zero energy? Because when you, of course, when you use the renewable energy, certain kilowatt hours per year, it has an equivalent carbon emission. So really that you are saving that particular carbon emission if you are using renewable energy. So if that is equal to the energy that is required to operate the building, maintain the building, there you are, net zero energy building is there. Right, now net zero carbon building, again, the same thing. Operation and maintenance carbon emissions must be equal to the on-site renewable energy generation carbon emissions. When you use the renewable energy, you are saving certain carbon emissions that must be equal to the operational and maintenance carbon emission. This is where net zero carbon building comes. Right, now these are the techniques that you can use to do the calculations. Of course, architects are not that much fond of doing calculations, but I am different. I do a lot of calculations on that. And of course, this is very important. You must calculate the net zero performance index. Net zero performance index is total on-site renewable energy kilowatt hours per year divided by total annual energy consumption per year. If the net zero index is greater than 1, you are achieving net zero energy. If it is less than 1, of course, you are not achieving, but there is an offset gap. Now, for example, I am giving this calculation for the Dubai Sports Complex. Here, I have got these figures, and if you want to know how it was done, maybe you can contact the organizers, and I can send you a copy of that calculation as well. And of course, we did not make 100% net zero energy, but we achieved 87.5% net zero energy. That is by producing energy with renewable sources. Now, let me explain this to Kuala Lumpur International, sorry, this Maldives International Airport. This is the digital twin that we prepared for this particular airport. Of course, when we put the sun path, we saw a lot of problems with this particular model. And you can see visualization is the best way to communicate with others. So that is what that I'm trying to show you. Here I'm entering to the departure hall, and here you have the receptionist. And after that, you have the serving kiosks where you can take your boarding pass, or you can see the flight information display board, and then you go to this particular counters to hand over your baggage. So it is very nice visualization. But digital twin, not only that, it helps us to study the problems of this particular building as well, because the western elevation was facing a lot of heat through solar radiation. I'll show you how we managed to counter that, because by countering with this front facade, we cut the energy consumption by 240 kilowatts per day, and we saved 720 kilograms of carbon emission per day. How did I do that? Now, I'm not achieving 100% here, but I will show you how I did that. Now here, this is the issue. Now you can see this is the original design. This is the western front corridor that you can see. This corridor is 500 meters long. It is a western facing corridor. It's exposed to evening sun. So solar heat gain inside to the building. Now, if it is that, the thermal discomfort is there for the passengers, because these passengers should walk from departure hall to the arrival hall, and from arrival hall to the seaplane terminal. It's about 500 meters. It is really 500 meters, not about. And of course, when this facade was introduced, we were saving 720 kilograms of carbon emission per day. In fact, we proposed this particular facade not because of merely energy concern, because the president, His Excellency, the President of Maldives, called me to his office and told me, Nihal, this elevation is not our culture. You are gone with European culture. I want to see Malaysian, Maldivian culture. Then I asked, Your Excellency, tell me what is your intention? What is your culture that you want to reflect? He said, I want to reflect ocean waves, because Maldives, you have all the sea around, plus white sandy beaches. So this is the wave, this is the white sandy beach, and our architect was very clever to convert ideas into the reality. Now this is what we did, and by that we improved the carbon neutrality, and we managed to reduce the carbon footprint. Now lower internal heat, lower electricity, fewer carbon emissions. Now you can see here, now this is an image. This image that we produced from the digital twin, and this was done even before I start foundation piling work, because I knew what I'm going to construct. I can visualize. Now that way, in the planning and the design also, digital twin simulate terminal layout and operations in real time, so we can avoid this congestion and we can ensure the smooth operation. You can see the path for the flight to come and park also is defined well on the ground. Now you have a lot of ramp services, ramp equipment around the flight. So we have marked all the locations based on the space available in the space planning. So digital twin allow us to make efficient airports and saving energy, and that will reduce the carbon footprint. And in addition to that, as a future provision, we designed the roof to mount photovoltaic panels to harness the solar energy. And that is also going to sort of make this particular building carbon zero target. I'm trying to reach that. And there was another clever thing that we did. We did study the temperature of this sea water. We found from 25 kilometers away from the terminal at 5-meter depth, the water is having a temperature difference of 6 degrees centigrade. That difference of thermal energy is sufficient for us to run the whole cooling system. That I have done the calculation with my design team, and we have proposed. Of course, when they have money to implement that, I'm sure that they will implement. And again, that we are reaching toward the carbon zero target if we implement both these photovoltaic panels and the thermal energy extraction. So this is how things are happening in our part of the world. And of course, being a responsible professional, I should always take care of the environmental effect. So this is a big issue, and I make sure wherever I go, I have this intention and mentality. Now, of course, doing all this design work, everybody explained that you can put sort of sensors to monitor the density of occupation and all the temperature. But using artificial intelligence, of course, you can control the energy consumption again, and that is also towards reducing the carbon footprint. Now, let me show you this. This is Dubai Safari digital twin that we constructed in Dubai. And this digital twin was done by SketchUp, and the architect has designed that as concrete framing, A-framing structure. When it came to me, I said, boss, this will not work, and I want to convert that into a structural steel building. And of course, we took this as a design and build contract again. And having done that, what I did, this is the physical asset that we constructed. This is the digital twin that we started working on. Now, the advantage here is that steel has a very good quality by which that you can always have a higher strength to weight ratio than concrete. Now, here I use 145 metric tons of 8 millimeter thick S355 steel plates produced in EAF. That means electric arc furnace. Now there, you are reducing the carbon emission by 75% when compared with the blast furnace steel. So as architects and engineers, we must always encourage our clients to understand this principle, because 75% carbon emission reduction is not a small thing, right? And then here you can see that I have done my installations of framing. So this framing is very light. I was using 8 millimeter thick plate. Now, if it is a box section and 8 millimeter thick plates, that will reduce the foundation load. So I'm using a lighter foundation than normal foundation. So I'm saving materials, I'm saving energy, I'm getting close to my net zero energy building targets. Now here, of course, I'm inspecting. I was the project manager on this project, but you know, when I converted that to steel, everybody started talking that Bin Laden is going to make a lot of money from this change and all these things. So it went to the Bin Laden himself, the news. Then he told me, Nihal, make sure that you personally inspect this particular structural fabrication. You being a structural engineer, of course, I was working as a structural engineer before in the same company, so he knows my capabilities. Now I did all this structural supervision as well. And then here you can see these steel box sections have a different, all that can be fabricated off-site with precise control, less waste, and fewer on-site emissions. So you are reducing the emissions because prefabricated. And if I start making concrete frame, I would have constructed extensive formwork, shuttering, wet curing, contributing to more carbon and labor intensity. So that I prevented by using this steel, and this is the final product that we produced there. And of course, you can see that I'm standing here, my height is about 1.5 meters. You can see the size of this element is about 1.2 meters, right? Now, this is how we try to get all our buildings close to the net zero level. Now, this is Dubai Sports Complex. What you see here is the digital twin, and here it is the energy building. Now, if you look at that, and of course, if I go to the inside, this is the image. This is not actual construction. Before starting the construction, we visualize, okay, I'm going to construct this. And of course, this was constructed for holding the FINA World Championship on 2010, December 10, and the date of completion is fixed. So I must use this type of technology to make sure that I do things exactly right, because I cannot make mistakes here. Now, this really helped me to get it done. And here is the place where we use this particular photovoltaic panels on the energy building to sort of augment the net zero situation. Here, we achieved 87.5% net zero energy. Of course, there was a 12.5% additional offset. I tried to use all the external lighting also with photovoltaic panels. Still, in my time, I couldn't do it. I don't know whether they have done it now. Now, here you can see the Dubai Sports Complex actual construction. Look at the image of actual construction and design 3D model image. So most of them are same. And not only that, this model allows our construction people to understand what they are going to do and how they are going to do. Now, because it's an odd shape. So when you have an odd shape, it is very important that you have a digital twin like that so that you can communicate easily. And even the trusses that we constructed based on that particular concept, because 3D model allows us to get things fabricated directly according to the precise size, reducing the waste. So reducing the waste means, again, you are reducing the carbon footprint. Now here, this is the next image where when we developed the digital twin in Maldives International Airport, structural model was done by one structural engineer, MEP model was done by MEP engineer, and the architectural model was done by the architect. Now, even the passenger boarding bridges, the manufacturer, they have their own 3D model or the digital twin, and the baggage handling system manufacturers, they have their own thing. So we put all together and see how it will integrate. Now then you will find clashes. Now we use Navisworks clash detection software to find all these clashes also. These clashes will be sort of notified to us automatically by AI algorithms, giving a snapshot of where the clash is happening. So based on that, we can sit down with the architect, engineer, and other stakeholders to resolve this thing. Now, if you start resolving that on the construction stage, now I'm doing everything in virtually. Now, if you start doing it in construction phase, you will start breaking everything, wasting energy, wasting material, increasing the carbon footprint. So this is the way that you can utilize digital twin to your advantage. Now, in addition to that, when you are developing the digital twin, you must give the information to your modeler about the work breakdown structure. Everything what is in the construction, you should give the sequence of your construction. Now here I am showing you that, you know, the planning engineers have a nice thumb rule where they use decomposition of the scope into the packages. Each package should be completed within 4 hours or maximum 40 hours. So that type of breaking down will help us to get the progress also monitored, because if you delay in completing your project, you will be sort of, again, spending a lot of energy and you are not helping to reduce the carbon footprint. Now here, now I have done the plan installation as well as actual installation monitoring, and then I can see if I'm getting delayed, where it is, and all these things visually. So this is very important to use digital twin in such situation. So this is what the final product, and I hope that you understood the importance of the digital twins in reducing the carbon footprint. Thank you so much.
Thank you, Engineer Nihal. Now we really do understand what is the deeper meaning and the use of digital twin into sustainability. So it's not all about design, but more on to how are we going to reduce the use of materials and also on the economic side as well. So thank you so much. So for our final speaker, okay, so he is an architect that used to practice in the United States and get the license to practice in the state of Nevada and become professor back in Thailand. Eventually, he built his own consulting firm focused on green building and BIM. He sold it and become the executive top real estate development company in Thailand. And after he left the post, then he got into digital twin technology. And now he's the chairman of the listed company focused on lighting technology, smart city, and artificial intelligence. To give us the topic or to deliver us the topic about the digital twin for the net zero in building operations, may we have on stage architect Dr. 𝙀𝙤𝙜𝙤𝙤𝙜. Have the floor, sir.
Thank you very much. Can everyone hear me?
Loud
Hello?
and clear.
Yeah. Okay.
Thank you.
I can see that we have about almost 100 members here. May I assume that most of them are architects since we are in ACGSA? Can I? Yeah, actually, if this is a live stream, a live show on site, I will probably ask someone, are you an architect? Are you a designer? And raise your hand. But since we're online, I would just assume right now that all of you here are designer. Actually, I'm going to modify my content a little bit because the previous three guests have already mentioned many technicals about what is the use of AI, what is the utilization of technology, especially the word digital twin that has been mentioned. Okay, so I'm just going to wear the different hat to be the last speaker here. I'm just going to wear the hat of a businessman, which is what I am right now. I would say that I am a businessman, the business executive who has an architecture degree. And I'm the one who hired the architects, especially in the past decade of my profession here. So I'm just going to tell you a simple statement first, that net zero is never #1 goal of any builder. No way. Net zero will never be the #1 goal of any developers or builders or any business. Because why? It just doesn't really answer directly to the profit margin of the company. Maybe it answers something indirectly. Okay, so let's say what's the main problem of the business owner? This is your client, your architects here. Most of you have to understand what clients think. The problem of the client is a business operation, especially these days. How you're gonna find a revenue and how you're gonna get the margin correctly. That's the main problem. Okay, if your expertise, if your skill align with that problem, then you have value in this game. Okay, so where is net zero stand in this game? I was just gonna talk about this first before getting to the slide. Why would any big developers or big builders in the world want to do net zero? First, they want to do net zero to show to their client that they can. Okay, this is important. This is marketing. This is a marketing strategy. The big developers, they have so many portfolio, they have like skills, but then they want to show the market that, hey, if you want net zero building, I can do this. Look at this. This is my building. That's the example to show the strength. Okay. And especially if their client is a multinational corporation that they want to be in a net zero building, then it's almost like a requirement that they have to do, but they're not going to do it to every building. Okay, they're going to do to the building that serves that client only. So as an architect, you have to understand who is your client and who is your client's client, who pays for your client to get the money to pay you. So those are the ecosystem that you need to understand. So if you talk about the building that the client doesn't use for commercial purpose, if it's a building that the client own and operate themselves, like a factory, maybe they build their office, then net zero will less likely to be that important. Because if you talk about net zero energy, that, hey, I don't have to pay for my electricity bill, that's good. How much does it gonna cost? It's gonna go to pragmatic question like that, okay? It doesn't have to be net zero, sir. If you can reduce my energy bill by 15%, I would be interested to hear what architects or designer has to say already, okay? So in terms of net zero here, we talk about almost like a North Star concept. Look at all the portfolio that you have shown me for all the guests here. It's expensive building, guys. It's, I would say, unusual building. You're not gonna build that building every year in your architecture or professional career. Maybe you build it once in a lifetime, once in a decade or something. It's a special building, okay? That's why you have a special treatment. That's why they have all the checklists that you have to be award, you have to have a net zero, all those things. But that's not the building that consumes the energy of the world. The building that consumes the energy of the world is what? Factory, office building, like a shopping mall, those kind of things that is almost non-existent in the architectural magazine, right? But those are the things that cause problems. So let's talk about the problem of how people use the building. What is the problem of airport, guys? The problem of airport is all this emergency all the time. You have flight delays, you have the back delay, you have the bomb threat, you have all those, you have a double park over there. Then they use technology of digital twin, which I'll tell you about the meaning later, of how to solve that immediate problem, because they detect everything and they send the information to the decision maker to make decision right away. The problem itself in the airport is not that they have so many other problems that I have mentioned to you. The problem at the airport is that the decision to solve the problem is not processed fast enough. That's the key problem. So if the data comes in, the recommend decision is good, then we make decision fast enough, everyone's happy. So that's the problem of the airport. What's the problem of this wind farm? Let's say in the ocean somewhere. The problem of wind farm or the wind turbine farm is that it's impossible to repair, guys. Can you imagine going into the ocean and if something goes wrong, and then you have to set the tower and crane to repair those things? No way. So if something slightly look wrong, they need to know right away. Oh, that thing start to look wrong. That machine doesn't really perform and generate the energy as target. Maybe something is already wrong. They need to start planning. Maybe they need to think about creating a new turbine right away. And for the next 3 months, they can go and ship when the monsoon season is not there. So these are the sensitive things that it cannot go wrong. It's impossible to do the corrective repair. It has to be preventive only. Okay, what's the problem of the bridge? The problem of the bridge is a safety. And most of the time, this is a Sweden, Norway case that has 2,000 bridge, and they have not enough people to just monitoring the bridge. So they want the real-time data if the bridge goes wrong. If the structures start to go wrong, they're going to close the bridge. Who closed the bridge? Not the structural engineer. Police close the bridge. Sheriff close the bridge. Maybe the teacher in that area, who is a government authority, has to come close the bridge. So we need the real-time data as fast as possible. We need a recommendation from the system that is neutral, no politicized recommendation to solve the problem. And those are what digital twin in my definition here. I'm just gonna skip this one. Okay, so what's digital twin? I have written this book, Digital Twin Execution, which is involved a city, building, and infrastructure. This is in Thai language, by the way, but you have AI if you're interested, I'll send to you, to your country. One thing that's important, guys, we talk about digital twin, you must have a physical and digital entity go together. Digital twin is a replica of physical environment that collects the real-time data to optimize the performance. Performance of the bridge is for safety. Performance of the wind turbine is produce electricity. Every infrastructure has a purpose to serve something for us, human civilization, to go forward. So it tracks, analyzes, and optimizes sustainability performance if we're going to talk about net zero. So if we go to the net zero frame, it's going to be the main problem for them to solve. They're going to track something that related to energy and carbon usage in real time. Okay, this is a picture of the digital twin implementation if your building is finished. We have 3 kinds of data. Previous guests is focused a lot already on the first one, which I call spatial data. It's design drawing, it's BIM model, it's SketchUp, it's simulation model, whatever you have put your software into it. We all in this profession familiar with this. And then the second one that we might not so familiar, this is not exactly a part of architects or engineer, but it's super important, which is a signal data. Signal data has 2 kinds. The pure signal data, which is like come from the IoT features, that you detect the temperature, you detect the energy use, you detect the water use. And another thing we call streaming. Streaming, which is a camera, something that you can see. And then there's an AI behind those cameras that help detect and make recommendations to solve the problem right away, to interpret the picture, the video. And the last one that we might not even familiar again is the memory of the organization, which called the system data. Most of the people who control this data is accountant of the organization. Is mostly money related data like P&L sheet, financial projections, and maybe the HR if they have a human occupancy. But so these 3 sets of data, first one we familiar, architects, engineers. Second one is the IT guy, the building maintenance. The third one is the accounting guy. We all need to work together to create the organization, focusing on built environment maybe. And then we immerse it into the data lake to have a digital twin platform. And then we see digital twin as an application that you just see 3 previous slides that I show you. But you know what? This slide doesn't really matter for the user. They don't care. They just want to know what they need to do. If the problem happens, this is us. I mean, we focus on this slide because we as an architect, I'm telling to every one of you, 90 of you already in the team, in the hall right now, you need to bring your value to the table to upgrade your skill in order for you to maintain your value in this profession, guys. If you understand all of this, you need to, at least this slide, you know that you need to work together with the IT guy, IoT guy, the streaming guy, and the accountant to understand all these things. So just go simple. Digital twin is the smart watch that you put on your building. What your smart watch do to you benefits you. Oh, your heart rate, how good I sleep last night, right? What is my so-called VO2 max, which I don't even know what it is in my watch. Too many data. But if you understand how to interpret data and give the benefit back to the building owner, that's your value. You don't have to be an architect that stops at the construction anymore. You come into the operation, charge more money, like, okay, be in a new business or something, right? So once again, the very important word here is the real-time feedback loop. Can you imagine if you have a faster feedback loop? Why some countries develop so fast like China? They have a super fast real-time feedback loop. They have problem, they fix, they have problem, they fix. Imagine you wear the smartwatch, you have a real-time feedback loop almost like in minutes. But in the past, if you don't have this, maybe you go see the doctor to check up your health. If you like rich, you might go like every quarter. You hear the feedback loop every 3 months. Now you hear the feedback loop every day. What's better? Same thing with the building. We need a real-time feedback loop to get the building correct. And this is reality, guys, that for me, this might contradict with other speakers. I think the real path to net zero starts when you occupy the building. Why? No way that you think people are going to use your building based on what you have designed. There's no way. Whatever you have designed, whatever your assumption is when you design, is not going to be the same when they start using the building. They're going to use the building their own way. It's just like the car designer. They think the car driver is going to act this and this way. No way. The car owner is going to do their own thing. Same thing here. The building will be modified. And can you imagine at the COVID time that we designed a building? After COVID, nobody's go to work anymore. And if you say that, okay, this building is supposed to be 1,000 occupied, and then suddenly the occupier go to 300, and then you say, oh, this is a success case. We have used less energy. Will you say that? No way, right? I mean, the world just changed. So we have to start the benchmark, the zero benchmark on the first day that you use the building and start going from there because it's all going to change. And sometimes the business go wrong, like they don't have the office anymore. They might need to change the data center. The energy goes up right away. Are you going to say you fail? No, the measurement is not for that, right? So this is just reality that you need to keep adapting and you need to reset the benchmark based on the game that you play. And I would say adaptation of net zero implementation is a constant process. Why? Benchmark keep changing, technology keep changing, the occupancy behavior changing. And once again, I have talked to a friend, talk about net zero before I come to this seminar. And my friend said, wow, if you want to have net zero, it's easy. Just build a building and don't let anyone go in there. Easy, right? Then it's going to be zero energy use, zero water use, and maybe it will be even net positive if you put the solar roof on the top. But why would you have a building in the beginning? So what I say is important, is so important that you have to use your life, spend your life normally in that building. You have to do the same thing. You have to use your computer, you have to turn on the phone, you have to turn on the air condition. But how you're gonna get to net zero base and that same behavior? You have to still be in business, guys. You cannot tell your occupancy or even your employee, hey, turn off the air condition for the whole day. We're gonna achieve net zero. No way, right? You're gonna lose all your employee. No customer is gonna come to your building. So how you gonna maintain, how you gonna keep more operation, how you gonna keep improve operation too, less energy, less carbon, but then your operation time is go longer. Your operation time is even better. How are you gonna do that? That's another question too. Okay, and you have to believe, you have a faith. Can you, I don't even know if you remember the world before we have ChatGPT anymore, guys. ChatGPT has been around with us only like a couple of years, right? But now we don't remember how we're gonna live without AI to consult anymore, right? For many of us. Same thing here. We're gonna have more toys and more technology coming in. So you have to believe that it's gonna be one day you're gonna achieve net zero with the building that you use like in full capacity. It's just coming. You have to adapt to something that it doesn't even show up today. So what I want to say is that holistic is important. In the past, you can see that all this software to track all the sanitary, CCTV, wastewater, garbage is separate. They have its own application. Like the architect Sally just showed that there's the application and technology to look at the bin, right? They have their own app and they don't talk to each other. So the smart building is smart in a certain function, but is so painful for the building facility manager because they have to run to 18 different screens to solve one problem. And within those screens, the drawing or the spatial data of the building is wrong. So what we need to do, we need to bring all the digital data together, spatial, signal, and system to integrate and understand. And that's how the dynamic and real-time feedback loop happens. So I'm just gonna go with a quick recommendation here is that first, the feedback loop that we do has to be shared. You're not just gonna have feedback loop and put it in executive room or the mechanical room and the expert to look. No, you have to share the result. You want this to happen, this is a human element. Achieving net zero, many of you talk about technologies already. I understand technology, but I would like to talk more about human role. The human role, if they understand together, we're on the same page, they will participate. Number two is that you have to support the function of that building. What is that building for? If it's a hospital, can net zero improve the patient satisfaction? Can net zero improve the doctor's service capability? That might be the question that we need to look next, right? We're not just gonna say net zero as a separate agenda, and then it will be lonely and nobody's gonna care about that. That's why I never go to number one agenda in the organization. And number three, here comes to the world. You have a budget. You have to say which one you're gonna do first. You're gonna do net zero, talk about energy first. You're gonna talk about water saving. You're gonna talk about waste. What you're gonna do first? You're not gonna be able to do it all. Nobody's gonna approve your budget that I want to do it all. And then the corporate executive said, this is all cost. That's no benefit. Revenue come out of that. No way, you do one, man. I let you do one agenda first. And then what is it? The next one is about adaptation to new technology. This is important. Many times you design the building and it's so ingrained, you cannot touch anything when you want upgrade. That's not right. You have to design all the entities that be ready to remove and replace a new thing all the time, almost like a software update. This part can be replaced, the energy part can be replaced, the water part can be replaced. Many of us doesn't even know how to remove the chiller out of the building because we haven't thought about that. We thought it's gonna be there forever, right? Okay, the excitement and competition, this is a human, can you imagine? You talk about how to compete with net zero energy. Is it more fun to achieve the number or is it more fun to beat your competitor in the next company? Of course, it's more fun to beat your competitor because now you say that I'm better. This is how we do it in the corporate world. Number is good, but comparing the number is even better with your competitor. And the last one, if you want to project the net zero building, you want to take the net zero building to the upper level to your client, show them the ROI. Okay, they understand that this is a cost, but what would they get? How long? 5 years, 7 years? They know that it might be just bullshit, you know, because what you do, you are an architect. What do you know about financial model and projection? But at least you try to think of something, you know. And they will be the one to make decision whether they're gonna believe it or not, and they're gonna run with the model and modify the model later on. But they know the importance. But if you want to sell to them, you have to be pragmatic, just like them. Okay. So last one, I go back to the first sentence that I say. Net zero is never going to be number one priority for architects in the project. Not even the owner, guys. What do you want to do, architects? You want to finish the project fast, make the profit, collect your fee, feed your employee. So no way that net zero is going to be number one priority in your design profession. So we need to be realistic here, but the value, net zero might be your competitive edge if you know, if you be able to implement. if you can explain to the owner what is it about. Okay, so just focus on making the implementation of net zero at least plain as possible for the owner. And maybe you go somewhere, maybe you get to do something real for the common people, not special building, just a building that you see all around you in your city. Thank you very much.
Thank you, Dr. Pon, for that very informative talk about AI and our management. So now we will gonna give the floor to everybody. This is an opportunity for us. We are now opening our question and answer portion. So may I ask our speakers to be on spotlight? Okay. And then, very sorry.
I'm here.
I'm still trying to find him, my brother. Okay. Chata, can you please help me to spotlight architect Sarli? Okay, there you go. I found you. All right. Now,
did you get it already, right?
Okay, so for everybody, for our audience, 91, we're all 91 here in the Zoom room today. Thank you so much for giving your time and of course, learning with us. You can freely turn on your microphone or raise your hand if you want to ask questions. I know very well that you already have a lot of questions in your mind, and please, we want to hear that and share it to us because I can see several information's already running in our chat group. Actually, I am copy and pasting it on our notes so that everyone we can also share that to others. So is there any question in our chat group or from the audience? Please raise. About design, about construction, what are the challenges? Anyone?
Hi.
Yeah.
I'm sorry, I tried to raise my hands, but I don't think it was like up.
All right. Okay, sure. No problem.
Yeah.
Will you please identify yourself?
Yes,
Your organization and country.
Yes, I am 𝙀𝙁 𝙁𝙤𝙤. I'm a PhD student, but I originally was from Thailand, but I'm currently studying in Aalto University, Finland at the moment. So I have some comment or something that I feel like it is important to share regarding to the presentation that Dr. Pon has just like an amazing in presentation. I would have to say that. I would like to say something about or address something about the importance of net zero emission for built environment, or at least share some perspective of what is happening currently in the EU. So I would say that I more or less agree with Dr. Pon when he mentioned that net zero is going to be very difficult to implement for building designers, or it would not be the main interest of the client, I would say. But in the EU, because they are how to say this, they take this very seriously. So about the carbon footprint of the built environment. So they have started to add this life cycle assessment as in their regulation. So to get the permit of the building, you need to have the carbon emission of the buildings as part of the permit package. And they plan to reduce or lower the baseline of number so that eventually they will reach net zero for all buildings. I understand it's going to be very far away for countries in Southeast Asia to catch up with this very ambitious goal. But I would say that with the regulation, like they are the future. That carbon net zero in built environment can be something like crucial to our profession. But one example of this is like in Denmark, when the government have set up the benchmark for the carbon footprint of the buildings in their country, they set up like a standard number, and then the architects, like the architect community in their country, when they see the number, they started to do demonstration to protest that the number is too high, that they need to be more ambitious, that they need to reduce the number even more, so that the building that they are being built in Denmark has to be more sustainable, or at least have very lower carbon than even the government wanted them to do. So I would say that they are, if we think about like carbon net zero for built environment as a positive thing, they are like possibility to do like more goods than what we can currently do. But it's going to take a lot of work for us. That's all I wanted to say.
Okay. Maybe I can comment a bit on this about Bob, because I think that's why in the World Green Building Council, they acknowledge that each country is different, because you can't be looking at sustainability goals when you are thinking about where your next food, your next meal is coming from. You have your hierarchy of needs, right? The problem where you are in the EU, the majority of people there have already satisfied their basic needs. So now they are self-actualizing that higher needs of net zero and whatnot. So from our analysis, because we are quite a diverse nation, we from Kuala Lumpur to some of the more rural areas, we can see that if you coming from an economically challenged background, it's very difficult to embrace sustainability. And I'm sure it's the same everywhere else in the world. So I think prosperity must go hand in hand with also sustainability, because or else it would not work.
One point I would like to supplement that, I think whether we really need to achieve the net zero or not, at least at this moment, we need to learn how to calculate carbon. We need to consider how to calculate operating carbon. That is not the job by the engineer. As an architect at the very beginning, we have to consider that. And then we also need to consider the embodied carbon. And that really related to the material we select. So right now, we have to engage the new skills, how to calculate it, and how to do it automatically and easily. That's why the AI can help us. I think the ultimate target, whether we achieve it or not, that's the goal, depends on different nations. However, right now, it really the paradigm shift. In the old days, we may lessly touch on the quantitative analysis on our design. But right now, because of the AI, because of the digitalization, that softwares can help us to have that dimension and make it more interactive, even the lifespan considerations. And that part are very, very important, no matter how far away on the carbon neutrality roadmap you are.
Let me add something to that.
Okay. Yeah, go ahead, Mr. Nihao. I'll finish it.
I started doing this calculation in 2007, and I did not have this AI there. It's not rocket science. It can be done manually also. But you have now AI, you can be super efficient by doing this calculation. So we must encourage everybody to protect the environment. So this is not a big issue. And I agree with Mr. 𝙀𝙤𝙜𝙤𝙤, because government also should put pressure on the consultants. Do this, use this. How the digital twin came? UK government make a ruling that you consultants will not get jobs unless otherwise you use digital technology. That's how these Autodesk and all these people catch the market. So Thank you for raising this issue like this.
I was just gonna speak this for the benefit of the architects around here, is that that's a saying. This is philosophical, you guys, very simple. What is your client problem? You need to understand your client's problem. And your client problem is mostly their clients. So you have a problem, most of your problem is your client, how you're gonna serve your client, right? Same thing, your client has a client too. And what is their client's problem? Imagine if your client is a factory, why would they need to do the net zero? You think because they want to do it? No, because they've been forced by the CBAM from Europe that they need to do the product chain needs to change, and they need to report this and that. And they said, okay, what do I need to do? I need to ask some architects to understand this. And if architects understand this, you have a value in the game. You can charge your fee. And if you don't understand, then you're not in this game. That's all. That's what I'm trying to say, is that understand your market, and you will be more powerful if you understand your client's client, or even better, your client's client's client in the third layer. And you will be even more powerful for you. So just for your benefit, guys. That's all. Thank you.
Thank you so much. Actually, I just want to add on another P in the triple bottom line of sustainability. I think one of the biggest thing that we need to identify there or to put into is also the policy. So it's not only people, planet, and profit, but there must be policy on the fourth P there. All right, so I can see one more gentleman raising hand here, Mr. 𝙀𝙤𝙜𝙤𝙤𝙤. Please have the floor, sir. Please turn on your microphone.
Hi, good afternoon from Dhaka. My name is 𝙀𝙤𝙜𝙤𝙤𝙤. I'm from I used to be the Environment Secretary of Institute of Architects Bangladesh. So it's a fantastic discussion and all that. I was, and many things that have been clarified regarding this, but the core question is how seriously the clients want to take net zero emissions as their sort of goal. And do you think that government encouragement or that sort of thing could really push this agenda further? And how can we, if the answer is yes, then how can it be sort of accelerated, that course? Like most countries like Hong Kong or the developed countries have fixed an agenda of going for net zero within 2030 or 2040 or 2050. And that's a goal, of course, and that could be revised or that could be extended. That's another issue. But that's one part. That how far can, we've been doing this for a couple of years now. Like this is not like we invented it yesterday. We're doing this for a couple of years. So how do you think the trend is towards the government rules or policies which are ensuring that more net zero buildings are being produced? That's one question. Another thing is that when we go into life cycle assessment and all that, there is a huge issue of post-occupancy evaluation or monitoring or continuous sort of looking after the whole system. How far, what about that? So there are two parts to my queries. Thank you very much.
Okay, who wants to answer it first?
I can.
Okay, sure, Dr.
Okay, of course, when you make it a law, it will force people to do things. But don't forget that, especially in a democratic country, as a lobbying power behind the scene, you try to draft up some law and it's gonna cost major player in the economy a lot of money, you're gonna get shut down easily, okay? So as another way to force people to do things is a market, just like what happened with CBAM in Europe. Right now, the government cannot do anything. If they don't comply with this, they cannot export. So everyone just have to go with it. So that's the game we play, okay? So yes, if we can make a law, it's done. If the law comes out and it doesn't make any sense, people will try to go avoid it by going into the black market, by bribing or whatever to get away with it, to make themselves survive. That's normal, okay? So the second one, the trend, you talk about the trend, right? The second one, am I? Yeah. The second one, the trend, to me, once again, I speak to 90 people in here. You have to know how to do net zero building, guys. As an architect, you need to know how to design, calculate, using all the tools of the great speakers here. They show you all the tools already. Learn that. When the time comes, when the cost is right, when the game is correct, the one who knows what to do things will get the job. The one who doesn't know will not get anything. So within this period, be prepared. Your opportunity is coming along. You need to practice, prepare now, learn the tools now. When your opportunity comes, you can say, hey, I've been practicing this for 3 years. I'm ready for war. You know, so those are the things I would like to say. So yes, be prepared. The trend is coming along. The cost and the problem will start to optimize, and that's your world. Okay, thank you.
Thank you. Thank you very much.
Thank you. Thank you, Dr. Kwon.
Maybe,
Dr.
mention
Tony?
about Hong Kong. I think I can share more insightful observations in Hong Kong. It may be different from other cities or countries because we are in a very small economy. So when we talk about net zero carbon, as mentioned in different speakers, and I think you guys understand what is the zero carbon or the carbon emission, basically divided in two parts, operational carbon and embodied carbon. I think for the operational carbon, we really already set a very progressive targets. By 2050, our whole cities become carbon neutrality, and even the whole China. And in the building industry, we just talking about the operating carbon, and it it's really have the key drivers because the electricity bills rising up. So that is the incentive for the for everyone to do the energy efficient building. And even for the government, we have the quite stringent policy to limit the energy consumption, not just new building, but also existing buildings. We have the roadmap. Let's say by 2050, reduce almost 14 to 65% based on the baseline. But what I'm talking about, just the operational carbon. Why? Because in Hong Kong, we don't have industry. We don't have manufacturer. So when we talk about the embodied carbon, somehow it will be some political issue because the carbon saving in the manufacturing process not really benefit to our own city. So if we pay for the low embodied carbon materials, some especially for the government project, that will be the financial concern, whether the carbon reduction really for the whole planet or really benefit to our own city. So somehow when we talk about net zero carbon or towards carbon neutrality, we really need to go in depth what we are talking about, and based on different cities, different countries, their situations or their roadmap, and really that's the point. Really agree with the Dr. Pong mentioned about you understand the client behind the client. So that is what my observation, but may not be applicable to your country or cities.
Let me add to that. When I was doing the change of facade based on the President's, His Excellency's instructions, of course, I explained to him that by this facade, we are going to save 720 kilograms of carbon per day. He was impressed and he agreed with the idea. And of course, I'm a contractor. If I do something extra, I will charge. So we charge $40 million for that change of 500 meters of facade. But by doing that, I got my relationship with him and I told him, this is our professional responsibility to reduce the carbon footprint. If you like, I can change the roof design to take the additional load that is coming from PV panels, which is peanuts. He agreed. Okay, you do the proposal, keep the provision. So I explained to him, you can reach to the net zero level. And then I went into the seawater to show him that the difference in temperature is 6, and I can cool whole your building with that cooling energy. So he said, okay, do your proposal. We will pay you for that proposal only. When we get money, we will do that. So this is how, as professionals, I would like to see you guys are acting. Thank you.
Thank you, Engineer Nehal. So I think we just have to accept one more because someone is raising hand here. But again, yeah, I think it boils down to let us understand what is the return on investment and engaging in the net zero building. So how are we going to convert the SROI or the sustainable return on investment into something, into such figures so that our client can able to understand that, hey man, this will be your savings after this. So that's the thing that we have to practice in our profession. So lastly, I would like to accept the question of Amorun Ruth. Sorry if I correct me if I'm wrong. Amorut Del Udomsat. Hi, madam. Hi, please have the stage.
Okay, thank you so much for all the panelists to sharing your experience, and we can see so many powerful tools for sustainability. But I have a question about if the data can be false or manipulated, doesn't that risk turning them into the instruments of greenwashing or something kind of like that? And how can we ensure the accuracy and integrity of the digital twin, the database, and what can we avoid or do the safeguards that should put in place to avoid that misuse? Thank you so much.
Who wants to answer?
I can answer that, no problem. Actually, it's simply said that data security is very important. It's part of the whole ecosystem. Thank you, Pix, for the question, because it's something that actually in designing systems for submissions, in designing systems for validation, security is very important. So I'm involved not just with GPI, but also on our board side. We are in Malaysia. We are trying to get all the payments from any project to go through the board of architects, and only then the board of architects pass to the architects. This is to like regulate the industry lah. But doing something like that means that cybersecurity number one concern, as well as data integrity number one concern, because inaccuracy, like what Nihal has shown us with the digital twin and all these things that Tony and Dr. Pon has shown us, if the primary data can be manipulated, then it's worthless. It's just it's something that is going to be a waste of time. It's just a greenwashing thing. But most of the time, when we do anything with regards to systems, there needs to be a procedure set in place. So usually these procedures are very strong because nowadays the bad hats, there are a lot of bad hats around. With the rise of technology, I'm sure in all countries, there is a big rise of scammers who use technology to scam people out of money. And I'm sure in the construction industry, there will be people who will use technologies to actually use bad data to weasel their way out of certifications or weasel their way out. So on our part, we need to implement better cybersecurity and verification. And perhaps AI also can help with verification of data, because sometimes the scammers also not very smart. They give illogical data, right?
Yeah. Okay.
Let me add, sorry.
Oh, okay. Dr. Nihal first. Dr. Nihal first.
Let me add something to this again, because you see, due to the time constraint, I removed 2 slides from my presentation. One is about the AIA published level of detail specification. The other one is the roles and responsibilities of BIM team and how you organize that to deliver the value that you want. And if you follow these specifications and the standards, there are many ways of safeguarding your data to be accurate enough to do a prediction. Thank you.
Okay. I would like, I love what Monrad bring up about the greenwash consideration. I would like all of you here to have time go and see the Volkswagen incident regarding they rigged their own system to pass the test. And the one who's commit this thing is not outsiders, guy, is the corporate themselves. Why they want to pass the test? They want to get the funding. They want all those things, right? So to me, very simple, guys. You need to share the data to everybody. If you think you're doing good, nothing to hide. You send it to all academics. You link the real-time API to the monitoring in any institution. Show, look at my building. This is real-time. You see something wrong, you tell me. maybe it's a mistakes. Maybe and once you're willing to share to everyone, then that's show the transparency. So my keyword is probably transparency. Tell it to the world, show it to the world. Link direct API to everyone. Free API. That would be easy to fix. Thank you. Yeah.
Good, good.
Thank you. So anything to add, Dr. Tony?
Yeah, totally agree. Actually, what happening in Hong Kong is that we need a third-party certifications. So that's why, as a professional institute, like in Hong Kong, the Hong Kong Green Building Council, we have the green product certifications, and also like what Dr. Pong mentioned about right now, the green certification is not just for the design or construction stage, really monitor the existing performance. So actually it's really shifting. So the third party or the professional institution, that certification or the monitoring is very, very important. Of course, that's why we all here architects or professionals. So somehow we also have our professionalism. So when we come across right now, it's not just we in the old day or right now, we have to check all the drawings, but in the future we also need to check all the digital deliverables. So that is what my sharing here.
Okay,
Yeah,
so thank you so much. Oh, anything to
I
add?
just put in
Yes.
to put the idea of transparency. For us at GBI and PAM, we are very transparent. So I shared in the chat, if anybody wants to look at our building's performance, that is the dashboard. You can see total building energy, and we share this with all our members.
Wow, this is exciting. So
yeah,
let's explore that one. Thanks, Arlie.
So you can just go to that link for our dashboard.
Okay, so due to the interest of time, I know many of us wants to ask more. I myself have a lot of questions, but then we need to end. We're almost come to an end. So again, to our esteemed speakers, distinguished ones, it is very insightful and very inspiring presentation today, really. So, and we truly appreciate your time and your expertise and passion you have shared with us for today. So may I ask Rachanta to share screen now of our certificates of appreciation.
Okay, Kap.
Okay, so this certificate is our token of gratitude. And this certificate, again, will be sent to you by our committee via email, maybe shortly after the event or next week. So please watch out for those in your inbox. So once again, I would like to ask our speakers for their final words. And of course, to thank each and everyone attending us here. So may I please ask the speakers again to be on spotlight. So may we start with Dr. Tony, just few words.
I think today even me, I learned a lot from our fellows here. So digital technology in architecture, that really make us, we are not just designing the architecture, we are in the process for the architecture, the whole lifespan. Even right now, we are what we are trying to is not just to consider whether our design is really to for the sustainability or not. We are really looking for the whole life cycle, the whole lifespan. So that is one belief for me. We are not doing the zero carbon design or sustainable design. We are doing the architecture or design for sustainable living or zero carbon living. More important is what the built environment we do, we facilitate our people to be in a more sustainable living style or the way. So this is what my belief and my sharing here.
Thank you for that, Dr. Tony. Architect Zarli, please.
Yeah, thank you for inviting. Thank you for sharing. Thank you, ACGSA and ACGSA. Keep up the good work. I think it's good sharing because sustainability is not just a single profession or single approach view, because at the end of the day, sustainability needs people to work together and understand in local context the most, because to solve each of these problems at a local level takes local knowledge, but with a global perspective. So I think sharing will perhaps interchange these ideas and perhaps better get and provide local solutions for all these planetary problems that we're having. So keep up the good work, guys. Thank you.
Thank you. How about Engineer Nehal?
Yes, thank you for inviting me for this presentation. And of course, I told you that I started this thinking, that I have a professional responsibility to safeguard the environment since 2007 when I started to this design and construction of Dubai Sports Complex. And after that, I involved in a lot of design and construction of airports and iconic buildings, where always I had the liberty of selling the product, saying that, yes, this is environmentally friendly, that we are making this and that can be to your advantage. So cultivate that good habits and try to practice your profession, keeping that in mind that you have a responsibility to protect the environment. Thank you.
Thank you. And last but not the least, Dr. Pong.
I would tell all the participants here to stretch yourself. Okay, that's the key word. Stretch yourself in a way of your mindset. Understand your client more deeper, your clients of your clients of your clients. Stretch yourself in terms of skill. Understand how to use all the tools to perform a better service to serve your clients. Stretch yourself in terms of scope. You're not only designing or construction. Maybe you need to start doing what other business do, which is the user satisfaction survey of your product. Sometimes your clients who pay you is not the one who use the building. What about the people who use your building? How do they feel about your building? So keep thinking about stretch yourself in this kind of dimension. You'll be able to achieve more value and you will have more play in the profession. Thank you.
Thank you so much. So actually for my conclusion here and my takeaway, well, I could say that digital technology, when applied thoughtfully, so it bridged our vision to precision. So AI and digital twins are no longer a future concept. They are present-day tool that empowers us as architects, engineers to redefine sustainability. It is not an aspiration, but a baseline of our standard today. So let's design with purpose. Let's innovate with intelligence. So before we end this up, I would like to call on our former chair, Architect Tushar Sugani, for the closing remarks.
Thank you. Am I audible?
Yes, we can hear you.
Thank you. Thank you. Thank you so very much. I think it was a very insightful session, and most importantly, I'm being very selfish to admit that we are just on the verge of a very premature verge of writing our rating tools from IIA, Indian Institute of Architects, So I think it was a very insightful session, and it actually acted as a catalyst to me when I'll be crafting those tools, because I come from a country where I've got 5 different climatic zones, So I have to be more judicious in drafting those tools, because my building, which is having been constructed in the cold region of Kashmir, cannot have the same rating tools which is there in the coastal region of Kerala or the hot and dry climate of Rajasthan, So I have to be very judiciously, and I think today's session has given us a very nice insight. And to start with, I'd just like to thank Tony, who talked about the use of judicious use. I use the word judicious use of artificial intelligence in reducing the entire energy consumption in the building. And when it comes to Sarle, I like your first slide wherein you just show when the electricity was invented, So we have actually transformed from those era when we actually discovered the electricity, and today we are talking about data privacy, what Pitt just now mentioned about. And yes, artificial intelligence cannot replace architects. Sadly, you very rightly said, but this is for sure. People will replace you if you do not use artificial intelligence. That's for sure. So I think the catch of the day today is you have to use it very judiciously. And yes, of course, Nihal, who is like a flavor to us architects, because we design, and the way in which His Excellency Maldives, asked him to design a different facade. And because, it would have come from an architect's eye, but the way in which you have integrated with your engineering skills, and of course the calculations, which we architects are very bad in. So you guys are like a flavor to us, because there was a time when architect used to do everything, used to design structure, used to design MEPs, but time has changed when our engineering professionals have actually enhanced this profession in a very dramatic manner. And last but not the least, Poon, I like your style, Of course, there has to be business angle to it. Unless if the business does not come into picture, I think nothing is going to happen. And we should always take this entire thing in blessing and disguise, because this digital adoption in the design process, I'll tell you, has actually given a lot of pleasure to the young budding architects also, because I'll be speaking on the behalf of architects. And trust me, there was a time, when I graduated, only architects used to be considered who used to design. The time has changed, because of all this technology adoption and implementation in the design process. It has given a lot of clutter business wise, I'm telling you, because you were talking about business. It has given a lot of business to us architects. There are the people who do a lot of simulations, calculations, there are green building architects, there are historians, there are specification writers, and it has only happened because of the help of technology. So I think in a nutshell, we cannot actually stop ourselves adapting this technology, but as the moderator mentioned, John, it has to be very judiciously used. And one more important thing for all of us out of this entire discussion came, that yes, we should not first create a problem, then, put our shoulders high in solving it. So we have to understand from our vernacular wisdom, which me, Acha, RF, everyone do a lot of advocacy in ACGSA. We have to understand the basic fundamentals of our vernacular architecture. We have to actually understand, the basic principles, what our ancestors were following, and we should not create any problems while designing it. So the catch is, do not create a problem and then feel very pride in solving it. Do it right at a grassroots level. So Poon, in that case, I think architects will play a very important role if they actually design their build form right at an initial level in a very holistic manner. And thanks to all the speakers, it was a very wonderful insight, and special thanks to Acha, who has been curating this, and our dynamic moderator, John, so it was a very fantastic, this thing. And as far as for ACGSA is concerned, we have been proud to associate with ACGSA Committee on Green and Sustainable Architecture. And just to give an update about our incoming events, we are going to soon meet in Incheon, where we are going to come up with a nice green AC art exhibition. This is going to be, suppose, either 6th or 7th edition, when we have been physically displaying all the best green building practice from 24 different member institute. So please help us in getting more and more entries, but that has to route through your institute definitely. And you all are cordially invited again in the city of Jaipur, Agra and Delhi, where we'll be doing next ACGSA in the year 2026. And our theme is bringing back, the vernacular wisdom. So I think we should not forget our past and try to get some good essence of our ancestors and try to carry forward those legacy in a very good design practice. So I thank you all, and thanks all the speakers and all the organizing committee for making this session a great success. Thanks.
Thank you, Architect Shah, and see you in Jaipur.
Thank
So
you.
we're looking forward for that Art Asia. So next year, right? And this year in Korea. So again, thank you so much for those who have attended. And according to our committee, this is recorded and will be played again. All right. So again, thank you so much. And always remember, let's act intelligently, build sustainably. So thank you and have a good day to all.
Thank you all.
Thank
Thanks a
you.
lot.
Bye-bye. Thank
Bye.
you.
Thank you very much,
Bye-bye.
everyone. Bye.